This is a review for Chapter 8, Chapter 13, and Chapter 14. Solve triangle ABC. That means to find all the sides and all the angles. Here we have a right triangle, so we have 90 degrees. We have 46, so 90 minus 46 gives us 44. So our missing angle over here is 44. Then we're going to look at our trig to figure out the two missing sides. So the sine of 46 equals the opposite side over the hypotenuse. Multiply by the hypotenuse to calculate that opposite side. So 11 times the sine of 46, be sure you're in degree mode, gets you 7.91. And then cosine of 46 gives us the adjacent side, adjacent over the hypotenuse, so multiply by 11. And we get 7.64. Notice how the angles are pretty close to 45. If they were 45, they'd be exactly the same. If they're close to 45, then these two values are pretty close to each other, which is what we have here. We're going to let theta be an acute angle of a right triangle. So we'll make a right triangle. We'll pick either of the acute angles. We'll pick this one. The sine for this triangle, the opposite over hypotenuse, is a reduced fraction of 5 to 6. So we'll just call the opposite over hypotenuse 5 to 6. So to find the other trig functions, we also need to know what this adjacent side would be. So to calculate that, we're going to say leg squared plus leg squared equals hypotenuse squared. So we can calculate that this side is the square root of 11. We won't consider the negative square root since it's geometry and it's a length. All distances are positive in our geometry. So to fill out clearly, the sine is 5 over 6. Cosine of theta is adjacent over hypotenuse, square root of 11 over 6. Tangent is going to be opposite over adjacent, so that's 5 over the square root of 11, which needs to be rationalized. So it's 5 square root 11 over 11. Then we can come up with the other three trig functions. Cosecant is going to be the reciprocal of sine, so it's 6 over 5. Secant of theta is going to be the reciprocal, so it's 6 over the square root of 11. Then you got to rationalize that to get 6 square root of 11 over 11. And then cotangent is the reciprocal of tangent, so we're going to say 11 over 5. Use the original format, and you don't have to worry about rationalizing. We're going to draw the angle and give a measure in standard position. And we're going to find a positive and negative coterminal, another angle that points in the same exact direction. So when we go around, we go counterclockwise from the positive x-axis. Straight down would be 270. We're going to be a little less than that. This is 255 degrees. What other angles come from exactly this direction? We can calculate a negative coterminal and a positive coterminal. The negative is going to be 360 minus the 255, and that gives us 105. So we'll call that negative 105. Is the negative coterminal. The positive coterminal is to just continue around in another circle by adding 360 to our already 255. So we get 615. 1,000. 1,000. We're going to go around a circle once to get to 360, a second time to get to 720. 720 and 90 is 810, 900, and then 100 more degrees would be just off to this direction. So 100 more degrees is 10 more than 90, 10 more than that 90. So this seems to be 10 degrees in there. So this is 280. The positive is going to be 280. You could also get that by subtracting 360 several times from 1,000. Will get you down to 280. The negative coterminal is what would be left. So if this was 90 originally, and it's 10 degrees past, so this is 80. So negative 80 would be this angle in here. Here we have a radian measure. We can see that 3 goes into 20 6 times. So 2 for 2 pi, 4 for 4 pi, 6 times leads us right back to a 0 degrees. And then we need, that would be 18. Another pi over 3 and a second pi over 3. So in this location we would get 20 pi over 3. That would be 6 pi over 3. That would be 6 pi over 3, 12 pi over 3, 18 pi over 3, 19, 20 pi over 3. So a positive coterminal would be 2 pi over 3, because that would be 1, 2 past the x-axis. And a negative coterminal for this would be 1/3, 2/3, 3/3, 4/3. Negative pi, negative 4 pi over 3. You could calculate that also by subtracting 2 pi from this multiple times, and you would get those same two results. We're going to convert. The conversion that we use is pi, in this case it's pi over 180. These are both standing for the same thing, so it's a value of 1. The degrees cross out because one's on bottom and one's on top. So we have 135. 45 goes into this 1, 2, 3 different times. 45 goes into this 4 times. So to get to negative 135, it's also known as negative 3 pi over 4. (11 pi over 6). 11 pi over 6, we have 6 pi over 6, 12 pi over 6 would be all the way back around, so 11 pi over 6 is 1 of the pi over 6 short. So pi over 6 is 30, so it's 30 degrees short of 360. But you could also calculate that by saying 180 over pi. Put the pi on bottom, and the pi's cross off. The 6 reduces with the 180 30 times, and we get 30 times 11 to come out to be 330 degrees, which is what we talked about here, being 30 degrees short of 360. So that makes sense. We could have another one. -1/4, -2/4, 3/4, 4/4, 5/4. That's where we'd be talking. So we can, this is pi on top, so we have to put pi on bottom. So that means we put 180 on top, put the degrees value on top. Cross those out. We got 180 times 5 divided by our 4, and we're going to have -225, which 45 and 45 make 90. Another 45 and 45 would make a total of 180. And getting all the way another 45 is 45 more than 180, which is 225. It's in the negative direction because the original was negative. Here we have a point. It's not necessarily on the unit circle because it's more than 1 unit away, but it's still the same concept. We go 9 to the left and 12 up. We make a right triangle that stands on the x-axis. We have our angle. We know we're 9 to the left and we're 12 up. We have a leg squared plus a leg squared equals a radius squared. So 81 plus 144 equals r squared. 225 equals r squared. So the r value is 15. So to figure out the 6 trig functions, sine is going to be opposite over hypotenuse. So that's going to be 12 over 15, which reduces to 4/5. Cosine of theta is going to be -9 over 15, which is -3/5. And tangent of theta is going to be the opposite over the adjacent. 3 goes into that 4 times, 3 goes into that 3 times, and it should stay negative. Doesn't matter which side the negative's on. Then we would have the reciprocal of sine, which is 5/4. The reciprocal of cosine, which is -5/3, and the reciprocal of tangent, which is -3/4. We'll go 6 to the left and 9 down. We still don't know what the radius is for this problem. So we have to do -6 squared plus -9 squared equals r squared. 36 plus 81. And together, those two values will come up to 117. So r squared equals 117, and r equals the square root of 117. So, often I like to start with sine. From our x-axis, our opposite over hypotenuse is -9 over the square root of 117, which by rationalizing the denominator, we get -9 square root of 117 over 117. The cosine is going to be adjacent over the hypotenuse. Rationalize the denominator. We'll get negative 6 square root of 117 over 117. The tangent is opposite over adjacent. 3 goes into that 3 times, 3 goes into that 2 times. So it's 3 halves, or 1.5. The reciprocal of sine is going to be square root of 11, or actually square root of 117 over negative 9. The reciprocal of cosine is square root of 117 over negative 6. And cotangent is the reciprocal of tangent. Here we're going to sketch our angle. We're going to find the reference angle. Negative 260. We have negative 90, negative 180, negative 270 would be going straight up. So negative 260 is 10 degrees short of straight up. So if it's 10 degrees short from standing straight up, then it is 80 degrees from the x-axis. That is your reference angle. You can call that 180. We got 260 total minus our 180 gives us 80 degrees. We never call a reference angle negative. 5 pi over 3. This would be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. So the reference angle is the angle that forms with the x-axis. So in this case, this would be 2 pi, known as 6 pi over 3. So the remaining amount here is pi over 3. A way to do that is 2 pi minus 5 pi over 3. We make common denominators, and we get pi over 3.